All right, so this is 12.3.37. We have 2 brands of car batteries, both carrying 6-year warranties. Were sampled and tested under controlled conditions. 5 of each brand failed after the number of months shown. So we want to calculate both sample means and both sample standard deviations. And then we're going to decide a couple of things: which brand of battery lasts longer and which brand has the more consistent lifetime. Okay. All right, but let's start with, and we'll talk about how we decide on this as we go through the problem. Let's go ahead and calculate, first of all, the means and then the standard deviations. And I'm just going to talk about this as the standard deviation because we calculate the means in the process of finding the standard deviation. Okay. So the sample, first sample A right there. So let's go ahead and identify the standard deviation for A. Okay, so that means that I'm going to be using the alternative formula that I presented in the lecture. And that alternative formula is the square root of the sum of the x squareds minus n times the mean squared all over n minus 1. Okay, so let's start by calculating the mean for A. And so I've got my values here, these values right here. So we are looking at 71, 68, 72, 67, 69, and 5. So this ends up becoming 347 over 5, and so we get 69.4. Okay. And since they asked us to do this as a part A, I'll just go ahead and calculate the mean for B as well. So here's our values for B. Okay, and so we're going to have adding those up. And then dividing by 5, and we see here that we get 329 over 5, and that is 65.8. All right, so this is our standard deviation formula. Let's go ahead and do these one by one. So this was part A. They ask us to calculate both sample means. Let's go ahead and calculate both sample deviations now. So the other thing that we need in this formula, we found the mean, we need that. N is just the number of values that are in the sample. And then we need to calculate the sum of the x squareds. Okay, so let's go ahead and do that. So for set A here, I've got x and x squared. My x values, 71, 68, 72, 67, and 69. When we square those in this column, I've done this ahead of time, so here's your values, 5041, and etc. Just write these down here. Okay, so the sum of the x squareds then for A, for this sample set A, is just going to be summing this column right here. And when you do that, you're going to get 24,099. Okay. All right, so we can go ahead and calculate the standard deviation for A. Remember that our x bar from A was 69.4, and then our squared was this 24,000 number. So I'll plug those in. So we're going to have 24,099, and again I'm using this formula right here. Okay, so that's the sum of my x squareds minus, we had 5 data values, and then our mean was 69.4, and we're going to square it all over n minus 1, and the n here is 5, so that becomes 4 in the denominator. Okay, so if we go ahead and in the numerator here you want to square first, square this first, and then multiply by 5, you're going to get this number, 24,081.8, and that's all over 4. Do the subtraction, and you will get 17.2 over 4. Do the division, it'll be 4.3, and then take the square root, and you're going to get 2.07. Okay, so the standard deviation for the first set there is, for set A, is 2.07. Let's go ahead and calculate the standard deviation for the set B, sample B. Okay, so we need to calculate our x squareds again. Our values, 68, 68, 63, 67, and 63. When you square those values, you're going to get this. Okay, and then sum of the x squareds. Summing this column right here, you end up with 21,675. And then we can plug these values in, calculate our standard deviation for set B, or sample B. Okay, so our sum of our x squareds right there is 21,675 minus our n, which is 5. And standard deviation on this one, or excuse me, the mean on this one was 65.8, squaring it. And this is all over the 5 minus 1, or in other words, 4. Okay, so go ahead and square this, multiply by 5, and you're going to get 21,648.2 all over 4. Do the subtraction, you get 26.8 over 4. The division, 6.7, and take the square root, and you get 2.59. Okay, so standard deviation for this, for the sample B was 2.59. Then in part C, they ask us which brand of battery lasts longer. So that's part C here. So we want to know which brand of battery lasts longer. So whichever one has the larger mean is going to be the battery that's going to last longer. And that should make sense because these are measuring, you know, how long these last. So the larger mean is going to be the one that's generally lasting longer. So that here is A, I believe. Let's look back. Yeah, so the X bar, the X bar for A was 69.4, the X bar for B 65.8. So in C here, because this one's larger, it's going to end up being A. So that'll be the brand that lasts long, or the battery that lasts longer. In D, they're asking us which brand has the more consistent lifetime. And so whichever one has the less variability is going to be the one that's more consistent. And the variability is measured by the standard deviations. So if we take a look at the standard deviations here, standard deviation for set A is something 2.07, and standard deviation for B 2.59. This one has less variability. So again, it would be set A here that would have the brand that has the more consistent lifetime. Okay, and that's it in this problem.